Hello, I'm Doug Mbaya, and I'm a solutions architect at AWS. I'm a partner solutions architect, so I collaborate closely with our ISV partners, and we work together in integrating products such that our combined strengths help our customers. And today I would like to talk to you a little bit about how you can use SAS via Workbench and SageMaker to do some deep learning and then scale using GPUs and hardware acceleration on demand, such that it scales with your workload and then quickly scales down, and you only have to pay for what you've used. So really, via Workbench is for data scientists. It gives them the freedom to experiment very quickly with a user interface and multiple coding language supported. And the architecture is simple. It's what we call a split plane, which means that half of the part of the workload runs on the partner, which means SAS account, and then the other part runs on the customer's own AWS account. And then SAS via supports all the AWS regions and availability zones, and so it's instantly available for multiple users across the globe, essentially. Yeah. All right. Yeah, of course, there is also the cross-region support, which means you have your redundancy and make it available across more than one region. All right. So for this session, I'm going to talk to you a little bit about what is Amazon SageMaker AI, and then we'll look into a demo on how you can combine both via Workbench and then SageMaker AI to be able to run a deep learning training and inference. So what is Amazon SageMaker? It's a comprehensive machine learning service enabling businesses, data analysis, and ML ops engineer to build, experiment, train, and deploy their machine learning models. It supports both coding and no coding, so you don't have to know how to code to use SageMaker. So essentially the steps when you use Amazon SageMaker AI is you build your model, you train them, and then you deploy them to an endpoint from where your application can access it and use inference. By default, SageMaker supports a lot of algorithms, and you can see them there: classification, vision, forecasting, like DeepAR, one of our popular time series model. And so those are what we call built-in algorithms. They are already there. You can use them as is, or you can fine-tune them with your data so that it becomes a bit more knowledgeable of your data before you deploy them. The other way you also use machine learning in SageMaker is that we have what we call Jumpstart, SageMaker Jumpstart. It has additional models that we get from partners like Hugging Face. And here you have an extended list of models, including large language models that you can tap into. And those models tend to be pre-trained. And for, I would say, 60% of the use cases, they are okay to be used right away. And then in some cases, you may need to fine-tune them with your own data so that it becomes a little bit more knowledgeable on your domains, your own practical data. So there are multiple ways you can interact with Amazon SageMaker AI. One is the Studio, which is a user interface where you go, you click on the model, you bring your data, and then you click on train, and then deploy, and then you start using them. That's one way to use it. And the second way is through the API. And then so you have an SDK, and if you your language, your supported language does not have an SDK, you can just call the API directly. And our demo, we're going to use the SDK to show how you can train and deploy and run inference using Workbench as your interface. And then you can also access it through the console, and we'll also see what it looks like when we access it through the console. And I want to start getting inside a little bit to better understand how we prioritize the workload, parallelize them, so that it scales with your use case or your data, etc. So when you're trying to train a model, a lot of what happens in the background is that you're spinning up across multiple instances. Your instances may just have a CPU, but it could also have a GPU. And then so when you define the number of GPUs or number of instances that you need, then you can decide that I want to use the 5, 10 GPU instances, and it's gonna spin it up in the background and then parallelize your workload. And those instances talk to each other as they train. So they're very stateful. And then they also use storages like S3 or EFS to exchange data to increase the state awareness of the progress, for example, where the model is in terms of the training cycle. So you can also tune a model within SageMaker. So let's say you have your model, but you don't know what are the set of hyperparameters that gives you the optimal inference. And so you want SageMaker to help you actually look for the right parameters. So you can do two things. One, you can fine-tune your model, and then that allows you to not even to not even look for the right parameters. You just bring in your data, and then you fine-tune it. At the end of that, your model, which was originally just a general model, is now knowledgeable about your data and then your domain or even your problem. And so the first step, yeah, we can fine-tune, we can automate the fine-tuning, and then it does it faster because you can parallelize it across hardware acceleration like GPUs. And then we support decision trees and neural network. So when you're doing a model tuning, for example, what it does is it tries to find what are the best parameters that gives you the most optimal inference. You have two choices. You come up with your own hyperparameters. You know that, okay, I have these parameters, they work well for me. Then you just plug them in and then go train your model. But if you don't have them, you want to experiment and find out what are the best parameters, hyperparameters that allows me to optimize my model. Then you can use the model tuning to be able to get the best model, essentially. And so we call it tuning or just hyperparameter tuning. Of course, when you do a tuning, it knows based on the parameters, the evaluation metrics, which one it has selected as your best model. And so you can just use the SDK and say, use what was the best model to be able to run your inference. As I said earlier, the training is very distributed. And so when you define your training job, you also tells the SageMaker how many parallelism you want in terms of how many instances do I want. If you say 5 or 10 instances, it's going to deploy 5 or 10 instances for you, and those instances talk to each other. So they're very stateful, and they know what the other instance is up to. And so that's why you're able to scale the training very quickly. We'll dive deep into the parallelism even more. But one of the things that SageMaker uses to exchange data, in addition to a networking instance talking to each other, they also have the ability to read data from S3. That's where it pulls the training data and the validation data, which you have to upload before you start your training. So you select how many GPUs instances you want, but also the size of it. You may select 10 GPUs, but you take smaller GPUs instances, or you may select bigger instances. So the bigger the instance is, the more GPUs it will have, or the more powerful the GPU will be. And so we allow you to specify how big should be your parallelism, how many instances do you want to actually spin up. And so this is just an example on how we actually configure the network so that each nodes talk to each other. What is fascinating is that SageMaker is per GPU level. So if you have a node that has, let's say, 4 GPUs, it's isolated on the GPU level. It's not on the node level. So it's going to know that I have this many GPUs with this many memory. And then so each GPUs talk to each other, exchange data. And then what that allows is that as you're training, your entire cluster of training is aware of what each node is doing, how much training it has completed already. And of course, now, once you have trained the model, you are happy with the metrics. You now need to productize it, because a lot of the times what we see is that you have been able to train a model, but then you don't deploy it in production, and models never make it to production. Well, with SageMaker, we made it even easier. So once you have a model, you like that model, you can just go and select that model and deploy it, and it's going to deploy it into an endpoint. And then that endpoint, you can then connect your application to it, and then start running inference. And those endpoints support individual inference. For example, if you want to do fraud detection, you send the information of one transaction, and it classifies it as fraudulent or not. That's one way you could do it. Or you can also do batch inference. You have multiple transactions at the same time that you want to classify as fraudulent or not. You batch them together and you send them, and then it's more efficient that way because it scales with your application. Imagine you are a huge bank in the US, which is present across all the countries. You have thousands per second transaction, and you need to be able to classify each one of them as fraudulent or not and stop them before they complete. And so when you deploy this to an endpoint, you also select what is the compute that I want to allocate to this, because the more compute you have, the more capable it is to take on multiple requests and then to scale with your workload. And as I just mentioned, you do a real-time inference, which means you send one request and then it classifies your data, for example, in a classification problem. But you could also do a batch inference, and then in asynchronous inference as well. This is new. This is when you don't need the result right away. You just want it to do it and then return the result when it's done. And so that is also supported. So depending on the criticality of your application, you may choose one or the other. And then that single endpoint supports both, so or all the three. So you can choose how you want it to be deployed. So all of this is serverless. So when you access SageMaker, you don't interact with a particular server, or you don't even know where it is. All you do is give me this specific server, what we call EC2 instance, and then I want this many of it. And then it's going to create it for you, then start training your job, and then when it's done, it's just shut down themselves, and then you don't have to pay for them. So it scales up and down as well. So when you deploy a model, behind the scene, you are actually deploying compute resources. And you can also get those compute resources to scale up and down. You can deploy a fix, you know how much compute resources you will need for your application. But if you don't know, you can also do an auto-scaling model where SageMaker monitors how much requests it's getting for inference and then scales up the backend to meet your demand. And then when your workload slows down, let's say it's evening, there's not a lot of banking transaction, it just shuts down. And then SageMaker also has a built-in model monitor. So you constantly want to monitor your model, check how it performs. And if you start detecting model drift, and by model drift, what I mean is that you may train a model, and then it does very well. It starts, let's say, classifying your frauds very well. But as your business evolves, the data changes a little bit, and then the model is no longer performing the way you want it. And then you notice that some transactions that were supposed to be flagged as fraudulent are no longer. So we call it model drift. And then so we monitor it, and then we let you know. You can even have a pipeline that actually retrain your model automatically once a model drift is detected, or just on a schedule. So all of this is built within the construct of Amazon Security, right? Everything is within the VPC, and it's locked in the VPC. In terms of the data that you're using to train is locked in the VPC. No one has access to it. And that's a VPC that you control. So there is no training of your data training sitting somewhere where someone else has access to it. Only you have access to it. And then as far as the actual infrastructure that trains your model, it's also isolated. It's managed by SageMaker, and it's also isolated in a dedicated VPC. And the communication between your data and the training, they're all encrypted. So your data is secure even in transit and at rest. And so when it comes to Workbench, this is a little bit what the deployment looks like. You have your control plane that's managed by SaaS. And then you have your data plane that sits on your account. And then now if you wanted to scale your deep learning using SageMaker, that's when you have a secure connection between your account and SageMaker, and then do the training. So I'll pause a little bit there and then talk about when would you use SageMaker and on top, in addition to Workbench. So Workbench can train a model and can run inference on its own. It can scale up and down as well. So in a lot of cases, there is a lot of overlap there. So where you really need a SageMaker is for a couple of reasons. One is you need SageMaker because you need access to much GPUs without commitment. Committing to GPU clusters is very expensive. So if you can do that for a few minutes or hours and then not have to worry about paying for them again, so that's one way to use SageMaker. And then also deploying the model endpoints. So when you've trained a model, you want your application to start using them directly. So you don't need to spin up a server and start writing code to run your application. You just click deploy, and then it's deployed to an HTTP endpoint, and then your application can talk to them. So I'll be going back and forth a little bit. I want to switch up to the console to look at what Workbench looks like, and then also what SageMaker looks like. So I may have to refresh my page credential expiration, so bear with me. But when you log into your Workbench environment, this is what you see. And then you can launch a notebook, and then you can use the SAS language, R, or even a Python library. And so that's going to create your Jupyter lab from where you are going to run your experiments. And then so you don't have to leave your SAS Workbench environment to be able to run deep learning with SageMaker. You say, oh, I'm sorry, you're not seeing, I apologize. Sorry. I'm gonna have to configure my monitor a little bit, so I apologize. Oh yeah. So I'm going to need a little help to get to switch to my my URL, my web URL, to be able to access SageMaker. It looks like I can do it from here. No, I need some help. Yes, I can't get away from my presentation.
Oh, press escape.
Escape.
And slide.
Yeah, well, I want to show my browser. I just can't. Yeah. Was that? No. I don't know if it's because I extended the monitor.
Maybe. So you might have to drag it over, or we could go to the other computer.
All right.
Yeah. So you extended the monitor. Just drag it over to the side.
Perfect.
And then you'll be up there, but you won't be able to see.
Oh, I won't be able to see?
You'll need to duplicate.
How do I duplicate them?
Back on your main desktop.
Yeah, bring it back on the main desktop and duplicate screens.
Okay.
Sorry, we're having some audio technical difficulties. We're working on that right now.
Okay, so how do I?
So you go to your settings. Go to displays.
Mm-hmm.
And then scroll up. We want, oh man, use as, go to advanced real quick. Okay, I'm not actually sure how to do this on a Mac. So if you switch from,
I'll pull it up there.
and you can come down if you'd like.
Yeah.
It's not a Mac, it's
It's at the top.
one of the top bars. One of the top bars on your thing is the screen. Those are the screens.
Yeah, one of the top bars.
Okay. Right. I'll try to do this. And so this is your workbench, and then once you launch a lab, essentially a Jupyter lab, you're able to access your Jupyter lab from here. And then you have a notebook, and then this is all you need to interact with SageMaker. You stay within your SAS environment. You do not have to leave your environment. Everything is going to be API based. So every inference that you do is going to be API based. So I'm going to quickly just walk you through the notebook. You do your authentication with your Amazon account. So you need a key, secret, specify the region, and a role that has access to training and running inference in SageMaker. So for me, I have initialized it in this Python library. And then so you specify a bucket. The buckets concept is very important, the S3 buckets, when you do deep learning with SageMaker, because it uses it to copy your training data and then to push it to each cluster or each node. Okay. And so we get the training data essentially. I'll switch a little bit on here. This is easy. And so you acquire your data, and then you discover your data. In this case, we just read. This is an image classification problem. And then you prepare your data, and then that's when you upload it to S3. You have to upload your data, and usually you split it between training and validation data. And then we containerize all models such that it's easy to parallelize them across instances. So so here I'm using a PCA model, Principal Component Analysis. And this model is a built-in model, but it doesn't have to be a built-in model. You can bring your own container with your own model, or you can use one of the models that are pre-built in Jumpstart, like large language models. And then so here is an important part, because you initialize your estimator, you set your hyperparameters. Remember, if you don't know which are the best hyperparameter, you can search for it using SageMaker. You can tell SageMaker, look for the best hyperparameters that you find, and then train the model with those hyperparameters and deploy the model. And so essentially when you call fit, it's going to run your training. And then once you have your training, that's where you click on deploy. Here, it's just going to deploy your model to an endpoint. I'm not sure if I can show you. Probably no. And so you go to, if you want to make sure that your job is training, you go to the SageMaker UI. And then from here, you go to training and inference. Inference is once you've deployed a model, that's where your model will be. And then training is where you find your models and training jobs. So this is where you will find your model. I don't have any model here because I'm not on right region. Right? And so you can see that I have the models that I have pre-trained just before we start this session. And then those models are already ready to be deployed. And so you just reference one of these models to deploy them with that deploy function. And once you've deployed the model, you can find them here in the inference. And then endpoints. Here, it's aware of all your models. And it's not deployed, it's just a model repository of all the models that you've trained. And then when you go down here, you have your actual endpoint. So I can call those endpoints to get inference. We can look at what it looks like. And so it gives you a lot of statistic on your model, how it's performing, whether it's used, etc. The memory. So you have all of these statistics. So we deploy it with this function. Of course, I have to reinitialize everything for it to work. It's probably not going to. So this is if you have your own hyperparameters, but if you do not have them and you want to search for them, you can actually ask SageMaker to search for your hyperparameters, and then it's going to tune your model to find the best hyperparameters. And then you can even pass your own data so that it tunes it with your own data. And so that's how you will do it. So I'm now running it live because it will take time, but I just triggered the work, and you can see that it's begin executing your work. You do not need to go to the SageMaker UI to interact with SageMaker. You do everything from the UI, your SaaS environment, and then you merge it with your SaaS workload. If you have some workflow that you're doing with SaaS, you just need to train a model in SageMaker quickly and then continue your workflow. You can combine them. So it doesn't have to be a dedicated notebook just for interacting with SageMaker. No, it can integrate with your workflow. And you can use any language that you have. If it has an SDK, you can use the SDK. If it does not have an SDK, then you can just use the HTTP endpoint. All right. All right. Now with me. Sorry, I'm just trying to work with the logistics. It's not easy. Of course, this will have my notes, but so what happens behind the scene is what we described earlier, right? The nodes talk to each other. There's a security layer built into it. There is isolation and CloudWatch monitoring. So if you want to go audit your training or your inference, how many people are calling the inference endpoint? What are they looking for when they call the inference endpoint? How long it's taking? All the monitoring is built in. So. Right. Right. All right. And so here, when you don't specify a name, it names it for you. But when you specify a base name, it's going to name it appending the timestamp on your base name. So that's how you have a reference on which model is it. And then here, I think we are deploying a model. You call the function deploy, and then you specify the instance type. So you can see here that I've specified a GPU-enabled instance type. And then down here, when I deploy it, I also specify a regular CPU-based interface. So, and then you can also deploy your model with a GPU endpoint. So that if the model is robust, it needs acceleration, then you can get it as well. All right. So I would like to leave a little bit of time for question if you have questions.
Please raise your hand if you have any questions. We'll bring the microphone right over. All right, you got one in the front.
Thank you for the presentation. Can you also quickly show us, if it's possible, of course, how you can use the deployed model? How can you call the model that it's already deployed? For example, you're training on like image classification. How can you later pass the image and based on a model that you already deployed and just have the prediction?
Yeah. So I think I have to debug this one, but essentially that's the last step, right? You can validate it, and then using your predictor, you predict it, and then so the way the way you actually call the endpoint is when you deploy the model, it becomes a predictor. In this case, there is a bug. Then you use that predictor to be able to run inference. So here is an example of a local inference. And then here we're using an endpoint. I'm just trying to find the... You can see that we're calling the PCA predictor that we deployed. And then we're calling the predict. And we're doing it here as well. So here we're just looping through the array. Here we're doing a single prediction. So you have to code your logic. Each model expects the data in a certain format. And so you have to code your logic to format the data the way your model wants to consume it. Here we have serialized the models in CSVs to be able to send it to the model. And then when you are done, you no longer need the endpoint, you can delete it. And then you just specify the endpoint, and then it's going to delete it for you. Does that make sense?
Yes. I mean, if your predictor holds in the same repository, probably you don't need to deploy, right?
Yeah.
So my use case is that when I'm done with the training and testing or whatever, and I'm like I know that this is the model that I'm gonna use for the future. I was expecting that model stays somewhere like with API, either calling with the API or in an app that I can use it. Like, does SageMaker works for that scenario, or it's just for training?
Yeah, so you can see that you have an URL here. So if you call that URL and then you pass it the inference data point.
That's exactly my question. Okay.
Exactly. So you will need to get that URL. In the notebook is just for your experimentation, right? But when it's in production, it's deployed in a URL that you can just call with an HTTP endpoint.
That was my question. Okay.
Yeah.
And SageMaker or like Amazon is handling that product like deployment in the URL, or?
Yeah. Once you call the deploy function, it actually deploys it here.
The URL. Okay. Clean. Okay. Thank you.
Yep.
Thank you.
Are there any more questions in the crowd? Oh, we have one more.
Do you know if there is like free trials or, I don't know, free versions for the students so we can get hands on the AWS for free?
Yeah, when you set up an account, you get free credits, trial credits. You're a little bit limited on what you can do with it. For example, you may not be able to spin up a GPU instance, but you may be able to spin up a regular instance to do your training.
Okay.
Yeah.
No matter we are a student, like I am a student or not, everyone gets like any specific like free trials for the students, or?
Yeah, you get free trial, it doesn't matter. And then I think we have some university programs as well. Depending on where you live, we have the Loft. Usually when you go to Loft, we help startups there and then students as well.
Okay.
And you may be able to get additional credits or resources.
Okay, got it. Thank you so much. Sorry.
If there are any more questions from the crowd, please raise your hand. All right. Otherwise, thank you so much, Doug. Let's give it up for Doug one more time.
Thank you.
We have a great general session coming up, so if you make your way, you'll be able to go see Brene Brown give a great conversation.